Good morning. Let's talk about complex numbers. When we take a square root of a number like, I don't know, 18, we reduce that by finding factors that we can take these square roots of. Now, the numbers we can take a square root of, well, 0 and 1, of course, but they're not very helpful. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. We've got 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 times 11, 12 times 12, 13 times 13. That should be plenty. So in order to reduce something like the square root of 18, we want to find a way to factor it. Since 18 is not in this list and it's not a perfect square, we want to find some way that we can factor 18 into something where we can take the square root of one of the factors. So 18 is 3 times 6, but that doesn't help because we can't take the square root of 3 and we can't take the square root of 6. 18 can also be factored as 9 times 2. And when you have a product in a radical, you can treat that as 2 separate radicals. The square root of 9 is the number 3. So the square root of 18 can also be written as 3 times the square root of 2. We can only take these square roots of positive numbers to get a real number as our answer, because the square root of, say, -1 is not a real number, since there is no number at all which multiplied by itself will give us a negative anything. However, at some point, they decided that we really needed a square root of -1. Because if we only had a square root of -1, then if we had the square root of -4, we could rewrite that as 4 times -1. So we'd have the square root of 4 times the square root of -1, which would be 2 times the square root of -1. The square root of -9 could be rewritten as 9 times -1. So we'd have the square root of 9 times the square root of -1, or 3 times the square root of -1. The 18 that we referred to before, if that had been a -18, then that would be the square root of 18 times the square root of -1. And we already determined over here that 18, square root of 18 can be written as 3 times the square root of 2. And this one would be times the square root of -1. So all we have to have in order to be able to take these square roots of all the negative numbers, we only need one more number, and that's the square root of -1. The problem is there isn't a real number. So they decided that it was an imaginary number, And so they decided to call it I for imaginary. So just like pi always has an exact value, I always has the value the square root of -1. That's why you never see I written as a variable. So the 2 times the square root of -1, sorry, can be written as 2i. 3 times the square root of -1 can be written as 3i. And 3 square root of 2 times square root of -1 could be written as 3 square root of 2i. Now you may see this written as 3i square root of 2 sometimes. The advantage about writing it this way is that there's no question about whether the I is in the radical or not. Never put I in the radical because I is already a square root. It stands for the square root of -1. And so if you had the I in the square root, you'd be saying the square root of the square root. Let's don't go there. So if we have something like the square root of -12, the easy part is the negative now. Let's just bring out the I, and that takes care of the negative. So the harder part by far is reducing the square root of 12. So 12 can be written as 4 times 3. So we've got I times the square root of 4 times the square root of 3. Since the square root of square root of 4 is 2, we've got I times 2 times the square root of 3. So we can write this as 2i times the square root of 3, or we can write it as 2 square root of 3i, making sure that the I is outside of the radical.